When you finish your quiz, or it's in 5th period since you've already finished your quiz, you're going to finish a worksheet for me due Monday. It's called Simplifying Fractions or Rational Expressions. I'm going to go through just the ideas of what you need to do in order to simplify fractions, and this relates back to things that you have done back in middle school. We're going to advance that and push it into algebraic fractions. So the first rule of thumb that you should always remember is always factor first. Never cancel before you factor. I'm going to show you some numerical examples like 1, 2, and 3, what factoring means in terms of those, and then I'm going to expand that idea into algebraic fractions. Once you have them factored, then you're going to reduce common or identical factors that occur in both the numerator and denominator. That is basically an equivalency of 1. So if you have two numbers over each other that are identical, you're really multiplying by 1, and I can highlight that a little bit as we go through some examples. So got a quick reference guide here for you. What you're going to do is you're going to factor top and bottom, reduce common factors in top and bottom, and then rewrite. So you factor, reduce, and rewrite. Those are your 3 steps. So even though you might do these differently, if you had these numerical numbers, what I'm going to show you is this procedure of factoring first, then reducing, and then rewriting. What we're going to do is going to rewrite 20 in simplest factored form. So what we're going to do is we're going to bring it down into its prime factorization. Now 20 is 4 times 5, and 4 is 2 times 2 times 5. Now those are the prime factors of 20. So what I'm doing is I'm basically showing you I'm going to factor the top, or the numerator, completely, and then I'm going to factor the denominator completely, which is 24. Now 24 is 4 times 6, and 4 is 2 times 2, and 6 is 2 times 3. So once I have it completely factored, then what I want to do is I want to identify any common factors that are in the top and the bottom. So this is what I mean by reducing common factors. They're going to be identical in the top and bottom, and really they're an equivalency of multiplying by 1. So if you have a 2 divided by 2, that's an equivalency of 1 over 1. Or we reduce the 2's and we have 1's. Again, we can do the same thing here, 2 over 2, which is 1. And then what we're left with is no other identical factors in the top and bottom, so our fraction is 5, 6. Final answer. Okay? And what I'm doing is I'm modeling the procedure I want you to do with these algebraic ones. Like I said prior to, probably when you first encounter a fraction like this, your first instinct is to say, what is the greatest common factor? What's the biggest number to divide into 20 and 24? Well, we know that 4 goes into 25 times. We know that 4 goes into 24 6 times, and we get 5, 6. And we can do that with actual numbers, but with algebraic fractions, it's much more difficult to find those common factors that, like 4, to take out. So. Again, another example of this, only with 25 and 45. So 25, first step in all these, I want to factor the numerator and denominator completely. So that's 5 times 5, and 45 is 9 times 5, so it's going to be, I'm going to write it as 5 times 3 times 3. Once they're completely factored, as I have them here in prime factorizations, I can look for the same factors in the top and bottom, which are an equivalency of multiplying by 1. A 5 divided by 5 is a 1. And what we're left with is no other common factors to reduce, so it's 5 over, and we're rewriting, and then these we're going to take 3 times 3, which is 9. So it's 5 nines. Final example of this, we got 30 over 60. We can probably very quickly see that it's going to reduce down to a half, but let me try to model again what I'm asking you to do. Factor the numerator completely first. So 30 is 3 times 10, which is 2 times 3 times, let's see, I had 3 times, let me do that again because I think I lost track of my numbers. I'm going to go 3 times 10, which is equal to 3 times 2 times 5. Okay, so then I've got the 30 there. And the 60, I'm going to go 6 times 10, and I'm going to keep factoring the 10 again. And the 6 is 3 times 2, and the 10 is 2 times 5, so times 2 times 5. I've got them completely factored. Now I'm going to find those that are an equivalency of 1. 3 divided by 3 is 1. 2 divided by 2 is 1. 5 divided by 5 is 1. So all we're left with are 1's on the top and a 2 on the bottom. So what you do is you take these remaining numbers and you multiply them. All the 1's on top, 1 times 1 times 1 is 1. We got a 1 times 1 times 2 times a 1, which is a half, which clearly we could see that from the very beginning. But like I said, I'm modeling the procedure here so that you can figure out what we're going to do. In this next example, example number 4, again, I'm just going to keep working through this reference. I also put on a quick reference guide for factoring polynomials, and we're going to be working with basically binomials and trinomials here. So the first thing I want to do is I want to factor the numerator and denominator completely. So I come up to my chart and I say, is there a monomial factorization? Yes, there is. I can factor out an x. So I factor out an x and it becomes 3x minus 2. Now that's completely factored. And then I'm going to look at the denominator. Well, the denominator, it's Doesn't have any monomial factors. It's not a binomial, so it's a trinomial, so we go straight to factoring into two binomials. So now we're going to use our analogy of FOIL. First, outside, inside, and last. In order to get a first terms of 3x squared, I have to have a 3x and an x. If that back sign is positive, we know the signs are the same, and they both have to be negative. The middle sign tells us they both need to be negative. And then we need to find some factors of 2, and the only factors of 2 that we have are 2 and 1. And we got to keep in mind we want to get a middle term of 5, so I'm going to put the 2 here and the 1 there. It's 2 times 1 is 2. I'm going to quickly visually test and make sure I get a negative 5x for the inside. So the outermost is negative 3x, the innermost is negative 2x, that's a negative 5x. So that all matches, so that's the correct factorization. Now, just as we did in the others, after we get done factoring, reduce any common factors they have on the top and the bottom. Well, this 3x minus 2 is exactly the same as the 3x minus 2 on the top, so that's really an equivalency of 1, so we can reduce them and make them each 1. Now, that's all the common factors that they have. This x minus 1 is in parentheses, so this is a fixed number of its own right, and this x is a fixed number. So this x is not the same as x minus 1. This is like a 10 over a 9 if you think of x being a 10. So it's x over x minus 1, and we are simplified. You cannot reduce these x's sitting here because they are not really factors. What you see there are a great temptation, but you have to stay away from them because a fraction bar is a grouping symbol, so that means these parentheses are really holding a number in check here, and this is a different number, and those two numbers are not identical. So that's the biggest temptation you'll have to try to resist and understand here. Moving on to question number 7. First thing I want to do is I want to abide by my rules of factorization. Sorry, didn't grab the right thing here. Just wanted to see this part of it. We want to factor the top and bottom completely. So the first thing I'm going to do is I'm going to take a look at this fraction, or numerator, and see what factors out. It does have a monomial factor, so I'm going to take out an x, and it's x squared minus 9. Don't always stop after the first one. So we said it was a monomial, yep. So we went and reduced it. Then we're going to come back here. It's a binomial, yep. Is the difference two perfect squares? You bet. So if it is, we're going to factor it into the difference two perfect squares. So this is going to end up factoring into x times x minus 3, x plus 3. And we have to rewrite over the top of my flow chart, but that's just the way it is. On the bottom, is there a perfect, or is there a monomial factor? You bet. There's an x that comes out of all three, so pull out an x. You're going to have an x squared plus an x minus 6. So then you're going to say, okay, I just factored out the monomial, came over here and did that. Then I'm going to come back, is it a binomial? Nope. So then I'm going to look at a trinomial. Yep. Now we want to make sure that we factor it into two binomials. So that means we're going to take out the x that we already have, and we're going to try to factor the x squared plus x minus 6. And if it is going to factor, the trinomial is going to factor to two binomials. So x squared is x and x, so there's my first, outside, inside, and last for FOIL. The signs have to be different because of the subtraction sign on the 6 and the negative sign. And factors of 6 that are 1 apart are 3 and 2. And if I double check the outside, inside, the outermost in the FOIL is a negative 2x. The innermost on the FOIL is a positive 3x. So that ends up collecting to a positive x just like we need, so that checks. So the next thing that we do is we try to identify any factors that are exactly the same. So there's two of them. These x's, the x over x, since they're common factors, can be reduced. That's an equivalency of 1. And we also have an x plus 3 and an x plus 3 that can be reduced, so we're going to take those out. That's an equivalency of 1. And what we're left with is an x minus 3 over an x minus 2. Now you can put the parentheses in there like they have, or typically what we do is we just take them out, omit them, because that fraction bar is an automatic grouper anyway, and it's redundant to put in the parentheses. So, okay, final example that I have for you on this, in simplifying fractions, is number 8. Number 8, the first thing I want to do is I want to check and see if there's any monomial factors, and in this case there is. There is a number that goes into 8, 36, and 20 evenly. I believe the biggest number that we can go into those is 4. So I'm going to take out the 4, and what we're going to be left with is 2x squared. And 4 goes into 36 9 times, so that's 9x. And then 4 goes into 20 5 times, so that's minus 5. Okay, so we just did the monomial factor. So yep, then we come back down here. It's not a binomial, so we're going to go to trinomial. And now we're going to try to factor this into two binomials. So since I'm going to run into that chart, I'm just going to squeeze it and come down this direction with it. So I got 4 times. Now I'm trying to factor this by using the FOIL. And the only way that we can get a 2x squared is if we have 2x in the first spot and x in the second spot. So there's our first terms. Signs have to be different, so we got a plus and a minus. At least I know that much. And then I've got to have factors of 5. And what we ought to end up getting is a 9. So if we do factors of 5, if I put a 5 here and a 1 there, that's 5 times 1 is 5. And then if I double check the outermost, that's a positive 10x. And the innermost, that's a negative 1x. That ends up being a positive 9x. So I know I have the top or the numerator factored completely now. So I got to keep that in mind. That's my numerator of my fraction. And then just kind of working with the space I have, I'm going to take this fraction, 6x squared minus 150. I'm going to come back up through here, and I'm going to see, does it have a monomial factor? And I believe there's a monomial factor in that one because there's a 6 and a 150. The largest number that will divide into 6 and 150 is 6. So I'm going to factor out the 6. It's going to leave me with x squared minus 25. Okay, so I factored out the monomial. Is it a binomial expression? What I have left is a binomial, so now I'm going to check. Is it the difference of two perfect squares? It is, so that means we're going to factor into the difference of two perfect squares factorization. So this, I'm going to show you down here, is 6. Now I'm factoring the x squared minus 25. The difference of two perfect squares is exactly the same values except for the sign in the middle, so x plus 5, x minus 5. And then what we're going to do is we're going to go and look for our common factors. Are there any equivalencies of 1? Well, there's one right here. The x plus 5 and the x plus 5 are identical factors, so we can reduce them. And then that's all of the identical factors that we have. But if we want to, we can come over here with the 6 and the 4 and rewrite it. 4 is 2 times 2, and 6 is 2 times 3. And now we have another common factor of 2 that we can take out. So I can get rid of this 2 with this 2, and that's an equivalency of 1. So reduce those, and what you're left with is 2 on the top times, we have a 2x minus 1 we didn't cancel, over, and we're going to put anything we didn't cancel on the bottom in the denominator. So we didn't cancel a 3, and we didn't cancel an x minus 5. So there's some examples on how to reduce fractions. The key to all of this is, if you look at that quick reference guide, is always to factor first, get your numerator and denominator completely factored, then reduce any common factors, and then rewrite. The biggest thing you got to remember is if you have something like x over x minus 3, this factor is different than this factor, and this fraction bar is the grouping symbol that's keeping you from reducing the x and the x. Another reminder is if you have x times x minus 1, all over an x times x plus 2, now these are factors, and these x's can cancel. So that seems to be the biggest difficulty that we have, and we struggle with identifying when that's a common factor or when it's just being added or subtracted. But use your fraction bar as a grouping symbol to help you with that. Also, you can use this flow chart that I created to help you with your factorization process. So look at this video, go back and reread it or re-look at it if you have trouble with it, but hopefully this gives you a good idea of how you got to simplify fractions. So now you should be able to work on simplifying. I think there's 15 problems on that, 15 or 20 problems that you need to do to practice the skill. So good luck, and I will see you on Monday.